Hello, statistics student. This video is for chapter 1.2. Part 3, we are going to talk about the third topics in 1.2, which is sampling method, types of sample, and also, when you do sample, what are the different ways of doing sampling? Types of sample, so if I collect a sample, we can, in general, uh, classify it as a random sample when every subject has a chance of being selected. And this is the preferred way of using the sample for inference, because if every subject has equal chance of being selected as a sample, when I say every subject, any subject in the population, then it is representative, right? A more ideal case of a random sample is a simple random sample where you will be collecting a sample of n individuals or subjects. So n is usually the sample size, is a number, is a letter that we use to represent sample size. That means any groups of n individual is likely to be a sample. So there is no particular grouping that is being prevented. So we call this a simple random sample, and a lot of mathematical um, calculations assume a simple random sample. And of course, the non-ideal one would be a non-random sample. So that means when you're doing sampling, not all the subject has equal chance of being selected, or maybe some are being excluded. And of course, we want the first two, right? Simple random sample or just random sample. So a good sample should have the same characteristic as the population, and then random sample or simple random sample can achieve this goal. So sampling method. How do I get a simple random sample? The way to get a simple random sample is you select the sample one by one using random procedures, or select them one by one by a random number generator. So then this method is called simple random sampling. Okay. The second method is called stratified sampling. So when you select your sample from the population, you first of all divide your population to groups first. And then, so usually it's a smaller number of groups, so maybe 3 sections, okay? Like depends on age, or depends on grade, or depends on gender. And then proportionally speaking, for every group, you have some representation. So this is a smaller group. So I pick 3. Oh, this is a larger group. I pick 5. And I pick 4, like that. So proportional to the group size, and so that would be called stratified sampling. So this makes sure that all groups had a representation. Okay, because if you do random sampling, it could happen that some of the group had no sample. Right. Third is called cluster sampling. So what is cluster sampling? Cluster sampling is you divide your population area into groups of or cluster. So usually we divide the population into large, more detailed section, and a lot of time is geographical, because of geography, because of location. And then you randomly select some cluster. You use a random process. So you use a random number generator. So you name these groups as 2. This is group number 1, group 2, group 3. But you select, so you can select some clusters. Sometimes you select 1, sometimes you select 2, sometimes depends on your sample size. But then after you select that cluster, you pick every member. So for example, in this case, I am going to select 2 numbers. So 1, 2, 3, 3 and 5. After I select this 5 group, I pick everyone from them. So combine all these together is my sample. And so this is called cluster sampling. This method is called cluster sampling. So the key word is you select all members from the selected cluster. For the systematic sampling, so the way to do it is, if you do simple random sampling, you have to generate so many random number, right? Systematic sampling will go from a list, just like in random sampling, you have to have a list. So sometimes you cannot do random sampling or systematic sampling, and then you randomly start from a place. After you start it randomly, you skip a certain number. So maybe you skip every 10th, or maybe you skip every 5th. Just fixed number. So don't change that number. Um, and then those would be the one that you pick. So you avoid needing to, you know, keep track of all the different random number. So this is called systematic sampling. 5 is multi-stage sampling. You would use a combination of the preceding sampling method. Maybe you do a cluster sample, but you don't select all of them, and then you do a stratified sample in the cluster, or combination of them. So multi-stage. Sometimes very big sampling study or statistical study would use multi-stage sampling. 6 is convenient sampling. So convenient sampling would be non-random. You just use data, or you choose your subject that are easy to get. So for example, get data from your friend, or ask people to volunteer to give you data, or sometimes we call it self-selected sample, a volunteer response sample. These are all convenient sample. Convenient samples very often are not representative, because not all the members in the population have a chance to be selected. So let's look at classifying. So someone described the way that they select a sample, and you to classify what types they are. Select 4 students by selecting the first 4 who arrive first. So that's obviously convenience, because you exclude those that come late, and you do not go through a random process. So it is a convenient sample. B, select 100 customer by selecting every 50th in the customer database. So every time you are skipping from a list, skipping around from a list in a fixed number is called systematic. Select 10 students randomly from each grade in a high school. So from each grade, you do randomly. So grade 9, grade 10, right? 11, 12, you from here you do randomly. From here you do randomly, but you would be selecting some from here, some from here, some from here, some from here. So that is called stratify, right? It is not multi-stage, it's stratified. D, select a sample of restaurant by randomly select 10 streets and select all restaurants in the 10 streets. So that is cluster, because streets are a group of the population, and then you randomly select the street first, and you select all restaurants in those selected streets. So that's cluster sampling. E, select 100 voters respond by posting a survey online. So your data are not selected by you. You don't actually pick your sample. The subject select themselves. So this is self-select. They select, they say, oh, I want to participate, or voluntary. So that is non-random, right? So these are not very good sampling method. And sometimes it is under convenient sample. You don't have to do anything. You just wait for people to come to you. And of course, people that have strong opinion will tend to respond. So it is not a representative sample. Another terms that we want to introduce along with sampling is sampling with replacement and also without replacement. Sampling without replacements means you actually, every time you pick a sample, you pick them one by one. And after you pick one, you put the name back. Yeah. So when you do a random number generator, if you say, I want to select number from 1 to 40, they do not know that a certain number is being picked. The next time you generate a random number, right? For example, let's try this again. What? Random number generator. So I want to generate a number between 1 to 40 because I want to pick a student. So 7. But the next time you generate, it could potentially be 7 again. They do not know that, oh, I have already generated 7, And I'm not going to generate again. No. Okay, so this is every time you do 1 to 40 is available to be generated. If you want different numbers, you can, skip them when you have a duplicate. But when you allow the same number, the same sample to be available to be selected, that is without replacement. Oh, that is with replacement. So with replacement is to put the name back. Okay, I think I say it wrong. So without replacement is you keep the name. Okay, you keep the name. And then the person will not be selected again. So this is you put the name back, like in a random number generator. So for example, in a random. So this guarantee that all subjects have the same chance of being selected every time. So in general, when we do sampling, we want to have no without replacement because you keep the name. You do not want the same student to be selected again. But in order for the sampling to be a simple random sampling, it should be a sampling with replacement. So in practice, simple random sampling is done without done with replacement. I think this is a wrong. Is done with replacements. When you do a random sample generator, you just do it. So every time you generate a number, any number is possible. So it's as if you replace it back. But when you do a survey, you would do it without replacements. You want them to be all unique because you don't want to interview a person twice, right? So if a population is small, sampling without replacement becomes an issue because you could the chance of having the chance of all subjects to be selected a difference after if the population is small. Okay, so in general, if you do sampling without replacement, your sample are all unique, different. If you do a sampling with replacement, that means you put the name back, you could potentially have the same person being picked twice. You could have the same person being choices twice. So sometimes it's fine, but sometimes you don't want to. So for example, can we say that these are with or without replacement? Let's look at this. Oh, egg comes up two times, so this must be with replacement, right? Because you put egg back after you select it. And all these are different, so it could be with replacement or without. With or without. If you don't put them back, so you would have all unique one, right? So that is get yourself familiar with these two terms. The wordings is a little clunky. Sampling error, non-sampling error, sampling bias, and also guideline of evaluating statistical study. We'll do it in the next video, part 4.